Well, hello, and welcome back. It has been a good long while. I've had a number of things that have popped up, but never fear. We shall continue. I'm AJ O'Neill, and this is Beyond Code Live. What we're going to do today is go over the vending machine. This is a common-ish interview problem and solution set. We're going to go over both. And there's variations on this. What I want you to be able to do is be able to recognize this style of problem and be able to basically, this is one of the things where I think that you should be able to solve this with your eyes closed, because it or something very similar to it is going to appear on a lot of interview questions, and it's just good practice of loops and general programming knowledge. So anyway, I will go ahead and for those of you that want to see the in depth, I go through this talking about the problem, kind of brainstorming around it, then go into the English description of it. Now we're going into the JavaScript. If you want to see that, check down in the doobly-doo for the prior links. But this one I'm going to do really quick overview and then jump straight into the code. So the basic problem is that you're writing a program for a vending machine, and the vending machine can tender these various denominations of US currency: $5, $1, quarter, dime, nickel, and penny. And you are to write an get ideal change function that, given the total amount of cash that the customer has put into the machine and given the total cost of the items that they selected, will return a collection of the ideal change. And what we did last time was go through this in English, just kind of trying to write rules, really explicit rules. If you haven't seen it, I would recommend checking out, what was it, in Exact Instructions Challenge? Yes, the Exact Instructions Challenge. I won't play this whole thing for you, but it's a dad going through the instructions of building a peanut butter and jelly sandwich with his kids, and he does it wrong 100 different ways. And so, as I always say, if you don't understand how to solve a programming problem, it is not because you don't understand the programming language, it is because you don't understand programming in your own native spoken language. So, what we have here is kind of the rules is we're going to be given total cash and total cost and the acceptable denominations, and what we're going to return back is going to be the ideal change would be the fewest of each denomination of currency. So we're going to keep a tally for each of these things, and so that these are kind of instructions that I hope if I gave it to someone that they could follow them and not get it wrong, even if they weren't good at reasoning things out, because intuitively you know how to give change. But this is how do you give someone the instructions to give change. So let the change do start at total cash minus total cost. And I put examples here, and then kind of a repetitive process for each of the denominations. So starting with the 5 and going down to the penny, we are going to increment the number if that denomination can go into the change that is left, meaning if it is greater than or equal to the change that is left, we're going to increment the tally of the denomination, how many of that we should give back to the customer, and we're going to decrement the amount due, and we're going to do that for each and each and each and each. So now that we've got this solved, we need to go ahead and put it in code. So come on ahead along with me to just.github.com, and we're going to call this vendingmachine.js. And we're going to go ahead. I'm going to copy over this English code here and try to pretty directly turn it into actual code. So first of all, anything that's a rule is basically a function. So we are going to write this function get ideal change. And I'm going to do it slightly differently than what I showed in the README, because I'm going to do it more accurately to what I have here. So we're going to be given total cash and total cost, and denominations I have listed here as a given because it's something that we know, but it's not something that we necessarily need to be given, although we could certainly do a variation of this problem where we can take arbitrary denominations, but that's not what we're going to do here. So I'm just going to list out yet one more time that we've got the 5, the 1, the 25 cent, the 10 cent, and 5 cent. Whoops. 5 cent and penny. So just so that's, whoops, clear in front of us. If I could actually, I've been touch typing for a long time, but I've never gotten the top row with the numbers on it. That one's always eluded me. Okay. So this is what the rule is get ideal change. What we're given is total cash, total cost. We are making the assumption that the program that will be consuming this function is correct itself. So we have to draw the line somewhere. Otherwise, we'd have to do lots of error checking and do error. And we can safely assume for the purpose of this. And this is something when I'm in an interview, I would ask this question to the interviewer. I would say, can I assume that total cash is always an integer and that total cost is always an integer, or is it a float, or what assumptions can we say will hold true? So we're going to say that these are both integers. We could say that they're floats actually, but maybe I'll go into that a little later. All right, so we got this part done. Okay, now what do we need to return? So ideally, at the end of this, we would be returning a tally of, and I'm actually just going to put this in here like this. Why not? Well, actually, there's a couple of reasons why not, but we'll just go with it for now because I've already started down this path. The main reason is that this is hard to type and it's not easy. Actually, here's what we're going to do. We're going to call this a 5. We're going to call this a 1. We're going to call this a quarter. And typically in the interview problem, it'll be specified how you're supposed to give it back. It's often as an array, or, but I'm going to go ahead and label this out as you see that I'm doing here. Oh, and by the way, I do have comments turned on Twitch and on YouTube. So if you do want to ask me a question, feel free to do so. All right. So we are not actually going to return that. Obviously, we're going to have tally equals. So we'll just initialize what we're going to return. Okay. Now we need to get the change due. All right. So we're going to say var change. I could say change or change due. Sure, let's call it total cash minus total cost. Is that correct? Total cost is going to be the lower number. Total cash is going to be the higher number. Again, this is something that you might want to ask the interviewer. Can we assume that total cash is in fact greater than or equal to the total cost? Because otherwise, we might need to throw an error and say, hey, you didn't give enough money. Okay, and then, yeah, I think it is really a good idea to go ahead and put an example in the comments in the code. I personally do this quite often, where I will put literal examples. And then I'm just going to put a note here. Note, currency is in pennies. So this would be 842 equals 1,000 minus 158. So actually, maybe I could just put it this way. All right. So there we have that. And what's the next thing that we need to do? So as long as I say just get really good at the basic for loop. Don't worry about the while and the do while and the loop. Just get good at the basic for loop, because every other loop can be done with a for loop. This is an infinite loop, or a while true, as someone would say. You just put nothing in there for it to evaluate. It'll keep doing that over and over again. So let's say as long as change due is greater than or equal to $5. So change due is greater than or equal to 500 is the denomination amount here. And so we have an initializer. There's no initializer, so we just put a semicolon. Then we put our condition, then we put the semicolon, and then there is no, there's a technical term for this. I forget what it's called, but the thing that happens at the end of each loop. So this right here is the same as a while loop. And like I said, just get good at using for everything, and you will be smarter, and you won't regret it. And if somebody asks you in an interview, why didn't you use a while loop here? Just say, it's all for loops anyway. Okay. So, I mean, I probably would use a while loop in an interview if I was doing this. But again, really, I do think it's beneficial just to be familiar with the for loop and the way that it works. Okay, so while the change due is greater than or equal to 500, we are going to do tally.5 plus equals 1, and then we're going to do change due minus equals 500. And it looks like we just need to repeat that for every denomination. So let's go ahead and do that then. So that's for the 100 and the 1. And this is, whoops. And this is for the 25. So we'll call this quarter. And we're gonna go through this, make sure that it works, do a couple of tests, and then we'll do some optimization on it. All right, so now I need to do the dime. So that's our 10 cents. And just, I'll do this quick aside just to show actually why we are working in pennies. Why would we not just use floating point decimal numbers with, 1.50? And this is why. 0.1 plus 0.2 is not equal to 0.3. So if we say, is this equal to 0.3? False. 0.1 plus 0.2 is not equal to 0.3. I'm not going to go into why that is right now, but this is why anytime you're dealing with numbers, floats are approximations. They are best guesses. Integers are exact. So when you need math to be exact, you must use integers. And when there's money involved, you want it to be exact. In fact, the whole premise of the movie Office Space, the problem that they have with the bank accounts and the rounding is all based around what I just showed you. I think it is anyway. It could be based around a similar principle that's just general to banking and interest. Okay, so now let me go ahead. This is where the problems come in, of course, because I have to go one by one and change each of these. So this is actually telling me this is probably not a smart decision the way I'm doing it, because I'm copying and pasting and making small changes that are likely to lead to errors. But it's good to go through the process once by hand, and maybe you get a couple of errors, maybe you do a little bit of testing and you realize that you left a nickel in twice or something like that. But it is good to kind of go through things the long way and then shorten up because it's easier to test each step of the process and whatnot. Anyway, so I think I've captured that. We've got our 5, our 1, our quarter, our dime, nickel, and penny. All right, that's good. And then we're going to return the tally. So I think that this is correct. Now what I need to do is to be able to test this somehow. And because we're doing this in JavaScript, of course, we can just test it right in the browser. So let's take, I think I gave an amount. Oh, the amount that I give here is actually, this is a good test value. So let's see what happens. If I'm just going to open up, this is what Command Option I opens up the inspector. So now I've got my JavaScript inspector open, and I'm on the console tab, and I'm just going to paste this in, and good. I didn't have any syntax errors. So now I'm going to just call get ideal change, and I'm going to give it my example values. So first of all, before I even do that, let me go ahead and I think in one of the versions of this that I was writing, calculated what that is. So let's just think through this so we know before the code even runs what the outcome is going to be. So change 500, it only goes in there 1. So this will end up being 1. Now at that point, so at this point we're dealing with 842, which means that at this point we're dealing with 342, which means that this will go in here 3 times, which means that at this point we will be dealing with 42. What a beautiful number indeed. Which means that a quarter will only go in there once, which means that here, oh, now we got to do, I'm better at addition than subtraction. So what do I have to add to get to 42? Well, not quite 20, because that would take me to 45. So that's, I have to add 3 to get 45, which means that I've got to subtract 3, so 17. Is that right? 17 plus 25, so that'd be 35, and then 40, and then 42. Yep, great. Okay, so with that, dime only goes in 1 time, and then that would mean that we're left with 7, and a nickel goes in 1 time, which means that we would be left with 2, which means that we would get a tally on the ones of 2. So what we are expecting is 1, 3, 1, 1, 1, 2. So when I run the code for the first time, that's what I should get with the example that I've started with. All right, with that in mind, and the stupid little browser plugins are running their thing in the background. So let's get ideal change, and we're going to pass in the numbers that we're passing in are 1,000 for $10 and 158 for the purchase price. So 1,000, 1, 2, 3, and then 158, and then look at that. Browsers autocomplete these days is so neat. So we've got 1 5, 5 1s, 1 quarter, 1. That doesn't look right at all. So something is really wrong here. So let's test the initial assumption, because you know what I might have done? I might have done bad math. So let's just check and see here what this looks like. Does this actually come out to 842? That does come out to 842. Great. Okay, so I didn't do bad math there. Then what's going on here? While change due is greater than or equal to change due. That just seems really odd. Am I looking at them in the wrong order? I am looking at them in the wrong order, perhaps. So it should be 5 and then 1. No, that just doesn't make sense. That just doesn't make sense. Okay. So, that's very strange. Let's think on this. So I think, you know what? Rookie mistake. I was testing the wrong condition, I think. Yeah, so this is as long as. No, change due is it? Hold on. Yeah, that seems to be right. Change due. Okay, so we're just going to do some console.log here. Change due. Let's say this is 500. And then this is the 100s. See how much change is due after each of them. Here I am talking about how you should be able to do this with your eyes closed. If you see what my problem is, feel free to point it out. let me go back here, get ideal change. So that looks right to me. So, oh, you know what? You know what it is? You know what it is? It's right there. That's what it is, the exact problem I was talking about. Okay, cool. So there we go, we've solved it. I'm gonna get rid of these now. So there's two problems. One, it reads in the wrong direction, meaning the output is not sorted in the way that I put it out. So, well, yeah. So dime, then 5. You know, what we want is 5, 1, quarter, so on. Yeah. So 5 is 1. That looks right. Let's see if we can compare to our tally. In fact, let's just go ahead and put this right here. So 5 should be 1, 1 should be 3, if I remember correctly. Quarter, I think everything else was 1, except that penny was 2. So let's just double check. 1, 3, 1, 1, 1, 2. 1, 3, 1, 1, 1, 2. 1, 1, 1, 2. Yep. Okay. That looks right. And then my output here is 5 is 1, 1 is 3, quarter is 1, dime is 1, nickel is 1, penny is 2. Good. So we're getting the right answer. Now, it would be good to test this with things along the edge to see, you know, like, for example, what happens if we just put in 500? Does that work? What happens if we just put in 100? Does that work? No, that does not work. Wait. Oh, whoops. Sorry, I meant to go in the opposite direction here. So what if the, is it total cash? Yeah, okay. So what I want to do is basically this. So 1,000 minus 500. There we go. So then I should see I get only 1 5 back. And then if I go down, I should see I only get 1 1 back. And then if I go down, I should see that I only get 1 quarter back, 1 dime back, 1 nickel back, and then 1 penny back. There we are. Okay, cool. So I could do more test cases, do, you know, +1 or -1, see how things play out. I could have a what we call a table test for this. But it's a relatively simple problem. I feel like this is good. I'm going to go ahead and save this. And now let's go make this a little bit better. There's 2 things that I think we can do to make this much better. So the first is, this problem is actually easier if we solve it with an array rather than with an object. So I'm going to make my tally to be, we're going to flippy do this around, where 0 is 5s, and then we're going to have 0 for 1s, whoops, 0 for quarters, 0 for dimes, and so on and so forth. And you'll see I kind of, my thought process goes multiple places at once. So I should probably explain why I'm doing this first. So let's if you can willfully ignore that change was made, let me go to what we want to do. So we've got a bunch of stuff we're copying and pasting. Now what's nice about this is we can go through and we can go step by step. We have unrolled this main loop so that we can easily go through and comment and have our example values and whatnot. But really all of this could be done in a more simple way. Well, this is the simplest way to do it, depending on what your definition of simple is. But let's go ahead and break this down into the denominations. And we will have a for each loop. And we could use a for loop on this one. but for each is a little more ergonomic. So what we could do is say for each denom d, I'm just going to call it d, for each d, we can say tally, and what we'd want to do is say d. So the tally of d is actually, yeah, we could do that, or we could do it. There's two ways we can do it actually. We could either use the denomination itself, so this would be 500, which would mean that if we were back in our other example, we can't, if we want to be able to do this in a loop, we need the tally to be accessible by information that we have, which means that either the index needs to match, which is how I wrote it up above here, or the name needs to match. So the name would have to be 500, 100 of each of those key value pairs. So let me write this out so what I'm saying is more clear. So we could also do tally like this. Maybe I'll do this way first, actually, because it's how we started. So we'll go and we'll do this first. So tally, 500 is 0, 100 is 0, 25 is 0, 10 is 0, 5 is 0, 1 is 0. Okay, so there's our tally. So that's us doing our tally as an object, and each key of the object is the number. So since I'm getting the denominations as a number here, and there's a one-to-one match, 500 to 500, 100, 100, 25, 25, 10 to 10, 5 to 5, 1 to 1, then it is safe for me to say for the current iteration, starting at 500, the tally of 500, and this is where I have to do my comments a little bit different if I'm thinking about this. So when this is 500, it's going to go from 842 to 342. And then when this is 100, it's going, and then the amount we get is 1. When this is 100, it's going to go from 342 to just 42, and the number we're going to get is 3. So I can still do the comments, but I want to think through each iteration of the loop. Anyway, so this is going to go up by 1. Change do is going to go down by the denomination. So for each iteration starting at 500, the change do is going to go down, and maybe I should actually put this first because logically that's how we're dealing with it. So change do is going to take the 842 down to 342 because we're going to be subtracting 500 from the change do, and then the tally of 500 is going to go up by 1, so on and so forth. So now I'm just rewriting this. Okay, so 42 means that the 42 goes to, what was it, 17, I think, and that's just 1. And then the 10 means that we go from 17 to 7, and we just have 1. And then the 5 means that we go from 7 to 2, and it's just 1. And the 1 means we go from 2 to 0, and it is 2. So this is just the syntax that I'm using to make this easy for me to read, which may not be the right syntax for you. The comment structure that I'm doing here, I'm just doing to make it easier for me to understand what's going on. So I kind of just made a table there of what's the denomination rolling through, what's the value going on, so forth. Okay, so I can still unroll the loops in my mind and come out with what the solution is supposed to be. So we're no worse for wear at this point. Now I can get rid of all of these. And I have less code, and my code is less likely to have errors, because as long as the keys of my tally match up with my denominations, if I change this, I have to change this. But that's it. I don't have to change the loop itself because the loop is just going to continue to function correctly. So let's take this new version and let's run it and make sure that we still get the values that we think that we should. So get ideal change, and there we are. So let's see, we got our 500, our 100. Okay, this does not look right. So something is off about this. What could be going wrong? Okay. So what I got rid of all the loops because I introduced a new loop. We can get rid of the loops. No, we cannot do that. So for change do is greater than or equal to tally D. So we could say amount equals tally D. Okay, now I think this is correct. So now we're not going to increment when there's nothing there. We're only going to increment when there's something there. Okay, let's try this one out. Let's bring it on over. Okay, now we went the other direction. All right, so, very strange. For change do is greater than or equal to the amount. Change do, oh gosh, sorry, I should have done just, this was right here. I was getting myself a little confused. I was pulling out the 0, which is not helpful. Okay, let's go run it again. All right, there we go. That looks right. 1 500, 3 100, so on and so forth. Cool. Let's make it so that we get no pennies. Let's go to, how would we get no pennies? If we went down by, it seems like we only have to go down by 2, but that doesn't seem right. But I'm going to go with, it seems like we have to go down by 3. But then why don't we end up with 3 pennies at the end? Why do we only end up with 2 pennies at the end in the other case? All right, so here we end up with no nickels. I will have to actually, because 2, when it's subtracted 842, not 158. Got it. All right, cool. So this looks right. So I'm going to go ahead and save this version of the code. I'm going to go just kind of, peek at the type ahead or the values that it gives us. Let me do the same thing as before where I say 1000 minus 500. So we get 1 5. If it's 100, we get 1 1. If we put in 25, we get 125, 10, 5, 1. Great. Okay, cool. So I'm going to go ahead and save this version of the code. And now we're going to make one more change to this because we actually have a loop that we don't need to have. I'm going to talk about this again in a near future video. I've been wanting to talk about this for a while, but I'm going to introduce mod. Now, if you're not ready for this, don't worry about it. Move on. You don't have to know this to solve this problem. You should know how to simplify the problem, or not simplify, sorry. You should know how to take unrolled loops and re-roll them, I guess is what I meant to say. Oh, no, there's one other thing that we're going to go over here before I make the switch. So what if we wanted to do the tally with just an array, not as a map between values? And did I already save this? I forgot if I actually click save on this or not. Hold on, let me go check revisions. Yes, we did save. Good. Okay. So let's say we want to use an array instead. The place marker is the index. So 5s are at index 0, 1s are at index 1, so on and so forth. We would have to change this ever so slightly. So 1, we want to be able to use the index of the array, which is the second parameter to for each that a for each function receives. So we've got D for the denomination. This is the value that's over here, and then we have the index. So at index 0 is the 500. So here we want our 500 to come first. So what we need to do is invert that. So let's go ahead and say, I want to show you what this does. So if we do this, we're going to get everything backwards. And there's a couple ways that we could fix that. But let me go ahead and show this here. So it's very clear what I just did. Whoops. It's very clear that I introduced an error because this needs to be an array. So now our tally is an array of a bunch of zeros. We're going to increment them. Oh, actually it did end up being in the right order. Okay, cool. So we don't have to reverse it. I was just thinking a little in reverse. So yes, 500 is the first here, 500 is the first there. We're good. So we can do that. And this could be, better or worse. The worst thing about this, obviously, is that it's the least clear to the reader. I'm going to go ahead and update this because it's working code. So let me go ahead and save that. But I'm going to edit it. I'm going to take it back because I like the other version better. Because that is just clear. It's easier for me to read and debug. So we're going to use the object, not the array. And what we're going to do here is we're going to get rid of this loop because we actually don't need it. And I will show you how and why. So what we want to do without doing a loop and counting up, we can actually add what number we need directly to the tally without going through a loop. And I'll show you how to do this. It's called mod. So we can do var num equals, so the number of this denomination is equal to the change due divided by the currency. So change due divided by currency, meaning if we have 842 and we divide it by 500, we want to get the floor value. So that doesn't, we know that there is at least one set of there's exactly one set of 500 in 842. If we subtract one set of 500, we get a number less than 500. So if we divide by 500, so change due here is say 842, and we divide by 500, we're going to get some number that's greater than 1. So let me just put this over here. So what was it? 842 divided by 500. We get 1.68. That's not what's important. What's important is that we just need to know the maximum whole number of times it can go in, which ends up being only once. So if we floor that number, let me just go back over here. If we do math.floor, it will cut the remainder. So now we know the number by which we need to increment the tally just by doing one mathematical operation. We don't need a loop of operations. Now, the next thing that we could do is we could say change due is going to be equal to change due mod the denomination. So for example, if I have 842 this is the remainder operator. Mod is remainder. So if I do 842 divided by 500, I'm going to get 1 in the remainder. I do math.floor to drop the remainder. But if I do mod, then I get only the remainder. So I don't know how many times it goes in, because, for example, let's increase this by another, we can increase it this much. So we can increase it by 1,000. We still get the same remainder. But if we go here and we increase it by 1,000, we get a different whole number that can go into it. So just to show that there. So hopefully that's clear. If not, just spend a little bit of time brushing up on math. But it's, what whole number can you divide and what remainder do you get? So with this bit, we know what the remainder is. So with the first part, we got the number we're going to increment the tally by. And with the second part, we get the remainder that's left over. That is the exact integer change. So with this, we've changed our program once again, and it should still be giving the correct value. Let me go ahead and go back to get ideal change here. Okay, yeah, something went wrong. I'm not surprised. Change to equals change to floor num tally nan. I'm a little bit surprised because everything should be in whole numbers here. What would be nan? It might be a divide by 0 problem. So is this ever going to be, this is never going to be 0. So let me just go ahead and console.log for each of these. Change do divided by d. Let's do math.floor. Change do divided by d and change do mod d. And let's see what that looks like and see if it reveals what I did wrong here. Interesting. Where it's 1, it becomes nan. Why would that be? That looks right. Oh, this right here. I didn't re-update the code because I decided to go back to the tally being indexed by the denominator, and I didn't update the code to be indexed by the denominator. I think that was it. I'm pretty confident in that, just looking at this. Yeah. Because, yeah, we don't have a 2 or a 3 or a 4 denomination. That was what it was. Okay. So here we are. And that looks correct again. And now we're using, there's a special name, I guess integer division essentially is what this equates to be. I've seen languages where integer division is actually, either typed, it can tell based on numbers being integers that's doing integer division. Or there was one language where the backslash did integer division and the forward slash did normal slash did float division. But in any case, in JavaScript, we don't have a way to do integer division, so instead we have to divide and then use math.floor. And what I mean by integer division is just that with integer division, if you divide 5 by 2, the answer you get is 2, because in integer division, you can only get integers. So that's what I mean by that. Anyway, so I think this is a super practical problem. I think this kind of wraps it up. We've gone through a couple different variations on the solution. I think this is a very practical problem. So you're going to face the same type of problem if you're dealing with money, if you're dealing with time, if you're dealing with sports teams and how many team members can be on a group. There are also interview problems like this that have to do with, say, soccer or football or American football or baseball and the number of players that can be on the field of a particular type. So you have your offense and your defense, or you have your infield and your outfield, or I think baseball's a little more strict on how many players you have to have on the field. But most of these, you have to have a minimum number and you can have up to a maximum number. And generally when you play, you want to have the maximum number, but sometimes people get injured and you have to go below the maximum number. In any case, this problem in addition to the vending machine, it's basically anytime you have to sort things into groups where the groups have a particular weight, and the problem can be more complex. Like I said, if you end up with one of the spores problems, there are often more rules, because whereas the denomination of a $5 bill is always 500 cents, the number of players in a particular position on a team can have some amount of variation, and depending on the interview problem, that might just get nixed, and it'll say, well, assume that it's exactly this number of players, and so on and so forth. But this is a type of problem that is so common and so useful and has so many different applications that it is something that you should be able to solve in about 10 to 15 minutes. If the variation's a little bit more complex, of course, because we're going through, you become a little bit more experienced, and you just jump to this. It's a very simple 5-line solution, right? Well, I guess it's a little bit more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10-line solution, but it takes a little bit of experience to get there. And again, if you were to do this exercise, do the whole way. Start with the very first part, put the comments in, expand the loops out, shrink it down, put the comments in, change it again from the loop to the integer division and modulus. Get that down. Just be familiar with it. Know how to label a problem as the vending machine problem. All right. Well, with that, I hope that you learned something. If you did, go ahead and give this a thumbs up. If you liked it, and if you want to subscribe, go ahead and hit subscribe. Check down in the doobly-doo for links to the live channel, the Beyond Code channel, and some of the other stuff that anything I find relevant, I'll put down there. And with that, I will catch you later. You have a wonderful night. Adios.